Chapter 10, Section 4, Independent and Dependent Events. The objective, to learn to find the probabilities of independent and dependent events. A compound event is made up of two or more separate events. To find the probability of a compound event, you need to know if the events are independent or dependent. Events are independent events if the occurrence of one event does not affect the probability of the other. Events are dependent events if the occurrence of one does affect the probability of the other. Example 1. Classifying events as either independent or dependent. Determine if the events are dependent or independent. A. Getting tails on a coin toss and rolling a 6 on a die. Getting tails on a coin toss has no effect on rolling a 6 on a die, so those events are independent. Letter B. Getting 2 red gumballs out of a gumball machine. On my first attempt, if I do get a red gumball, that does affect the probability of me getting a second red gumball. So this event would be dependent. Probability of independent events. If A and B are independent events, then the probability of A and B, we calculate that by multiplying the probability of A by the probability of B. Example 2. Finding the probability of independent events. An experiment consists of spinning a spinner 3 times. What is the probability of landing on 5 all 3 times? The outcome of each spin does not affect the outcome of another spin, so the spins are independent. In each spin, the probability of getting a 5 is 1 out of 5. So the probability of spinning it 3 times and landing on 5 each of the 3 times, probability of 5, 5, 5, would be 1/5 times 1/5 times 1/5. Please write that product as a fraction here and then calculate that as a percent over here. In letter B, what is the probability of landing on 5 at least once? Now think about this. The probability of at least 1 5 plus the probability of not 5, not 5, and not 5 has to equal 1, because the probability of at least 5 added to the complement of that, remember, has to equal 1. So, for each spin, the probability of not being 5 is 4 out of 5. There are 4 chances out of 5 that it will not come up as 5. So, the probability of not 5, not 5, not 5 would be calculated by taking 4/5 and multiplying it by 4/5 times 4/5. Please write that product here as a fraction and then calculate that as a percent over here. Now what you just calculated was the complement of at least 1 being 5. You calculated what will not be 5. If you think back to Chapter 10, Section 1, we learned that a complement of an event is everything but the event. If I add everything but the event and the event, that has to come out to be 1. So we're now going to subtract this probability from 1 to find the probability of spinning at least 1 5. So we have 1 and we're going to subtract this probability. That difference will be the probability of spinning at least 1 5. Please write that in here, find the difference, and then calculate that percent over here. In example 3, finding the probability of dependent events. To calculate the probability of 2 dependent events occurring, you need to do the following. Number 1, calculate the probability of the first event. Number 2, calculate the probability of the second event if the first event already occurred, and then simply multiply those probabilities together. So the probability of dependent events. If A and B are dependent events, then the probability of A and B equals the probability of A multiplied by the probability of B after A. Suppose you draw 2 marbles without replacement from a bag that contains 4 blue and 5 red marbles. Because the first marble is not replaced, the sample space is different for the second marble, so the events are dependent. Find the probability that the first marble chosen is blue. Find the probability of that first marble being blue. The probability of blue is how many total blue marbles out of how many total marbles in the bag. Please write that ratio here. If the first marble chosen was blue, now there would not be 4 blue marbles in the bag, there would only be 3. And there would be only a total of 8 marbles left in the bag. We need to find the probability that the second marble chosen is blue. So the probability of the second marble being blue is going to be written here, but we're going to write that assuming that the first marble was blue. How many blue marbles are left over? That goes in the numerator. And how many total marbles are left over? That goes in the denominator. Now, to calculate the probability of the first marble and the second marble being blue, we need to bring the first probability of 4/9 needs to be written here. The second blue marble, that probability needs to be written over here. Please write that over here. Multiply these together. Write down your probability as a fraction here. Then calculate that as a percent.